In the shadows of humanity's greatest space achievements lies a hidden tapestry of missions that rarely make the headlines. While the world celebrated the moon landings and Mars rovers, a select group of scientists and engineers were pushing the boundaries of exploration in ways that would never grace the covers of magazines or captivate global television audiences. These are the untold stories of NASA's clandestine missions, ambitious, daring, and sometimes controversial endeavors that have shaped our understanding of space, while remaining largely unknown to the public. Not only did these missions advance our technological capabilities beyond what was publicly acknowledged, but they continue to influence space exploration today, some 70 years after the first classified satellite launch. The story of NASA's secret missions isn't just about classified technology or covert objectives. It's about humanity's relentless drive to explore, to understand, and sometimes to gain strategic advantage. These missions represent us at our most ambitious, our most ingenious, and occasionally our most secretive. They didn't just capture data about distant worlds and phenomena. They captured the imagination and determination of generations of scientists working behind closed doors. I'm Alex, and you're watching Space Truths. And in today's exploration, we'll uncover everything you might ever want to know about NASA's most secretive space missions, from their Cold War origins to their surprising scientific legacies that continue to this day. It's one of life's little ironies that while NASA is often celebrated for its transparency and public engagement, some of its most significant achievements have remained hidden from public view for decades. The origins of NASA's classified missions can be traced back to the height of the Cold War, when space wasn't just a frontier for exploration, but a battlefield for technological supremacy. The stakes were astronomically high, and the line between civilian and military objectives was often deliberately blurred. Of course, the public-facing NASA wasn't initially meant to conduct classified missions at all. When NASA was established in 1958, its charter specifically designated it as a civilian agency devoted to the peaceful exploration of space. However, the geopolitical realities of the Cold War era created a more complex landscape. Just months after NASA's formation, a parallel program began to take shape, one that would operate in the shadows of the more celebrated Mercury, Gemini, and Apollo missions. When I look back, I realize how little the public actually knew about what we were really doing up there, says former NASA engineer Thomas Reynolds. We discovered things we didn't tell anyone were there to be discovered, time after time. So, are you curious to see what they learned? Let's start with one of the most consequential hidden programs, the Discoverer missions. At least, that was their public name. In reality, Discoverer was the cover for a highly classified program called Corona, America's first photo reconnaissance satellite system. While NASA publicly announced these as scientific research satellites, they were actually taking detailed photographs of Soviet military installations. Between 1959 and 1972, more than 120 Corona satellites were launched, providing vital intelligence that shaped Cold War strategy. The technology behind Corona was revolutionary for its time. Each satellite carried specialized cameras and thousands of feet of film. After capturing images, the satellites would eject film capsules that would re-enter Earth's atmosphere. In what might sound like something from a spy movie, these capsules were actually captured in mid-air by specially equipped aircraft. If the mid-air recovery failed, the capsules had flotation devices that allowed them to be recovered from the ocean. This might not sound like much, but was more than Corona needed. While a digital camera system might have been preferable, the technology simply didn't exist yet in a form that could be deployed in space. This long-term fuel capacity was no accident. You see, when Corona launched in 1959, the United States faced a unique challenge. The Soviet Union had just demonstrated their ability to shoot down high-altitude spy planes with the downing of Francis Gary Powers' U-2 aircraft. This meant that satellite reconnaissance was no longer just a technological aspiration, but a strategic necessity. There wasn't enough time to develop entirely new systems, and the United States government wouldn't earmark enough funding for a dedicated military space program, at least not publicly. So, what did NASA's covert teams do? They devised a series of engineering feats to optimize the Corona satellites for multi-purpose missions and fervently hoped that the funding would follow. Another key to its success lay in its deception. Each Corona mission had a dual identity, a public scientific face and a classified military reality. This dual-use approach would become a hallmark of many of NASA's classified missions over the decades. It provided plausible cover for launches that might otherwise raise suspicion and created a mechanism for sharing some scientific data while keeping strategic intelligence carefully guarded. But how did these incredible machines manage to keep their true purpose hidden for so long? It all comes down to that old but incredibly effective approach to secrecy: compartmentalization. Engineers working on one system might have no idea what those working on another system were developing. Launch teams might know the orbital parameters, but not the payload's true purpose. And the public? They would be told about vague Earth observation objectives, while the cameras pointed not at weather patterns, but at missile silos and military installations. The MOL program, or Manned Orbiting Laboratory, represents another fascinating chapter in NASA's secret history. Publicly announced in 1963 as a space platform for conducting military experiments, MOL was actually designed to be a crewed spy satellite station. Astronauts would have lived aboard the station for weeks at a time, operating powerful cameras and other reconnaissance equipment. The program selected 17 astronauts, many of whom later transferred to NASA after MOL's cancellation in 1969. What's particularly intriguing about MOL is how it foreshadowed later developments in space station design. Its planned configuration, a pressurized living module attached to a laboratory segment, bears remarkable similarity to later stations like Skylab, Mir, and components of the International Space Station. This underscores a recurring theme in the story of classified space missions. Innovations developed for secret purposes often find their way, eventually, into civilian applications. Durability was a chief concern during these classified missions. There are many unknowns in any space endeavor, but when your satellite is capturing images vital to national security, failure is not an option. The Corona satellites, for instance, had to be designed to function perfectly on the very first try. There would be no opportunity to send a repair team if something went wrong. This demanding requirement drove innovations in reliability engineering that would later benefit NASA's public missions. Even with all these successes, the truth about these missions remained carefully guarded for decades. It wasn't until 1995 that the existence of the Corona program was officially declassified, revealing not only its intelligence value, but also its unexpected scientific legacy. The thousands of images taken by Corona satellites have proven invaluable to archaeologists, who use them to identify ancient sites that have since been obscured by modern development. Environmental scientists use them to track changes in landscapes over decades. What was once a tool of espionage has become a unique window into our planet's past. Another classified NASA program with far-reaching implications was the Keyhole series of reconnaissance satellites, which evolved from the Corona program. These satellites represented quantum leaps in imaging technology and continue to influence Earth observation capabilities today. While many details remain classified, We know that these systems pioneered technologies like digital imaging and real-time data transmission that eventually transformed civilian remote sensing. But with all this technology, what did they see? Let's go back to the beginning and follow the path they blazed across the Cold War landscape. On September 13, 1959, a Thor-Agena rocket launched from Vandenberg Air Force Base in California, carrying what was publicly identified as Discoverer 8. In reality, this was the first partially successful mission in the Corona program. Though the film recovery failed on this attempt, it paved the way for Discoverer 14, which on August 18, 1960, became the first satellite to successfully return. Reconnaissance photographs from orbit. The images revealed Soviet bomber bases, missile testing sites, and nuclear facilities that had previously been hidden from Western intelligence. Together, this dynamic duo of civilian cover and military reality was set to take a dazzling parade of pictures that were absolutely revolutionary at the time. But don't take my word for it. Let's jump in, and you'll see for yourself. One of the most intriguing aspects of these classified missions is how they've influenced the technology we now take for granted. GPS, which guides everything from your car to the apps on your phone, emerged from a classified Navy program called Transit. This satellite navigation system was initially developed to guide nuclear submarines, but has transformed into a global utility that powers countless civilian applications. Similarly, weather satellites, communications technology, and even the Hubble Space Telescope owe aspects of their design to classified programs that preceded them. Lucky for us, the declassification of some of these missions has even allowed us to see their approach to technological innovation. Engineers working on classified programs often had to solve problems with limited resources and without the ability to openly collaborate with the broader scientific community. This constraint-driven innovation led to some remarkably creative solutions that might not have emerged in a more traditional research environment. But NASA's classified missions weren't limited to Earth orbit. As we pushed outward to the Moon and beyond, the line between scientific exploration and strategic advantage continued to blur. Some lunar missions carried classified experiments designed to detect nuclear detonations or monitor Soviet activities. The Apollo program itself, while primarily a civilian achievement, had undeniable strategic implications in the context of the Cold War space race. Something that immediately stunned the public when finally revealed decades later was the existence of the Hexagon satellite program, also known as the Big Bird. This massive reconnaissance satellite, about the size of a school bus, could capture images with remarkable detail. When some of its images were declassified in 2011, they revealed the extraordinary capability of these systems. From 100 miles up, these satellites could reportedly distinguish objects as small as a foot in diameter. The white blurry spots you might see in some declassified images are one example of the remaining secrets still kept. Even decades later, some capabilities remain sensitive enough to warrant continued classification. Turns out, government secrecy is littered with these selective revelations, and we're still waiting for the full picture. When we think space, exploration, we think NASA, but thanks to declassified data, scientists have long suspected that the National Reconnaissance Office, NRO, has been a silent partner in many seemingly civilian missions. While NASA gets the public credit, the NRO's technical expertise and funding have enabled capabilities beyond what would have been possible through public programs alone. This collaboration continues today, with technology originally developed for spy satellites now being adapted for scientific missions to distant planets and moons. Before we leave Earth orbit and continue our journey into the deeper secrets of space exploration, I promised we would come back to its human element, the astronauts who participated in classified missions. The MOL astronauts represent a unique chapter in space history. Selected for a program that would ultimately be canceled before its first crewed flight, many of these men later joined NASA's astronaut corps. Their training and experiences with the classified program informed their later work on public missions, creating a subtle but significant link between the classified and civilian space programs. Possibly the biggest shock from the declassified expedition records is the revelation about the space shuttle's role in classified missions. While the shuttle was celebrated as a versatile platform for scientific research and satellite deployment, it also served as a platform for classified military payloads. Between 1982 and 1992, the shuttle conducted at least 11 classified missions, with astronauts sworn to secrecy about their activities in orbit. These missions reportedly deployed reconnaissance satellites, conducted space-based intelligence gathering, and tested technologies that remain classified to this day. This photo shows a classified payload being prepared for a shuttle mission. In the 1980s, which is incredibly recent in the grand scheme of things, and totally unexpected for those who viewed the shuttle program as purely scientific. We now know the space shuttle as one of the most versatile classified mission platforms in history. At the time of these missions being conducted, it would have been incredible to comprehend the dual nature of the space shuttle program. Imagine expecting to see a purely scientific endeavor, and then stumbling upon the reality that some missions were entirely classified, with astronauts forbidden from discussing what they had done in space. These blue patches, worn by astronauts on classified missions, contained no mission details, unlike the descriptive patches of public flights. The secrecy was so complete that even mission control communications were encrypted during classified operations. This level of security highlights just how significant these missions were considered to be in the broader context of national security. The next phase in NASA's secret operations came with the development of stealthy satellites, spacecraft, designed to be difficult to detect from Earth. While most satellites reflect sunlight and can be tracked by amateur astronomers, these classified satellites reportedly employed special materials and orbital maneuvers to remain hidden from observation. Their very existence represents a fascinating chapter in space technology, one defined by the need to operate unseen in increasingly crowded orbital space. Today, we know of numerous classified programs that operated under the NASA umbrella or in close coordination with the civilian space agency. Programs with code names like Quill, Gambit, and Misty pushed the boundaries of what was possible in space while remaining hidden from public view. Each of these programs has its own fascinating story of technological innovation, operational challenges, and strategic implications. I don't know about you, but I find this hidden history so hauntingly resonant with our current space era. As new players enter the space domain, both national space agencies and private companies, the interplay between public science and classified capabilities continues to evolve. The lessons learned from NASA's classified history inform how we approach this new era of space exploration and utilization. But we've got a long way to go in uncovering the full story. So let's move on. One of the most intriguing questions about NASA's classified missions is, what remains hidden? While significant declassification has occurred, especially for programs from the 1960s and 1970s, more recent activities remain shrouded in secrecy. The capabilities of the latest generation of reconnaissance satellites, for instance, continue to be closely guarded secrets, with only occasional hints emerging about their extraordinary capabilities. As we look to the future, the relationship between classified and public space activities continues to evolve. Today's X-37B orbital test vehicle, an uncrewed spaceplane that can remain in orbit for years at a time, represents the current frontier of classified space operations. While officially described as a platform for testing reusable space technologies, its extended missions and classified payloads suggest more complex objectives. The legacy of NASA's secret missions isn't just about technology or strategic advantage. It's about the complex relationship between public science and national security, between open inquiry and necessary secrecy. These missions have shaped our world in countless ways, from the technologies we use every day to the geopolitical landscape that defines international relations. The story of these classified missions is a testament to human ingenuity and determination. Working in secrecy, often without the recognition afforded to their colleagues on public missions, the engineers, scientists, and astronauts involved in these programs pushed the boundaries of what was possible in space. Their contributions, though long hidden, have become an integral part of our journey to the stars. Thanks for watching. I was honestly blown away by all the declassified information that continues to emerge about these once-secret programs. The more we learn, the more we understand that space exploration has always been a complex endeavor, shaped by scientific curiosity, technological innovation, and, yes, sometimes, strategic necessity. If you enjoyed this exploration of NASA's secret history, don't forget to like and subscribe, and consider supporting Space Truths on Patreon. Until next time, keep looking up. You never know what might be looking back down.